Okay guys, so we're looking at page 65 in our student journal, page 65, and we are trying to solve nonlinear systems. So nonlinear systems, these are systems that may or may not be linear. If they're nonlinear, that means that they might be quadratic, they could be cubic, they could even be square root functions, lots of different types of nonlinears. The main ones we're going to be focusing on are a linear combined with a quadratic, or maybe two quadratics. So it's very similar to what we've been doing, especially number 2 in the warm-ups. That was a linear system, and we solved that. So we're just going to go straight into the practice problems here. We're looking down at numbers 1 through 3. It says in exercises 1 through 3, solve the system by graphing and check your solutions. Do this on your graphing calculator. So we're just going to do it on our graphing calculator. We haven't done this before with quadratics, but we have with lines. So let's go ahead and put in number 1 into your calculator. So we're just going to go into y equals. Okay, so once we have them all in, we want to check that we have them in correctly. One thing I notice people doing, and then they get an error message, is they put a subtraction in the start of an equation. That's not going to work. You always have to start the equation with a negative. In between two terms, if you want them to subtract, you have to make sure you use the subtraction symbol. All right, so now we're going to do a zoom 6 to make sure we all have the same screen. And here's our first function, and here's our second one. All right, so we're trying to find the solution. Is there anything that they have in common? So what would we say? No solution. So for number 1, we're going to say no solution. All right, we're not going to try all of these. Let's jump over now to number 3. Let's go ahead and put that one in. And we can just hit graph because we recently did the other one. So now we have a parabola and we have a line. Okay, so how many times does it look as though those intersect? Twice. So we're going to have to find 2 solutions here. So we're going to do second trace, calculate. We're going to go down to our intersect. You have to get close to the point of intersection. That's pretty close. So now it's going to say, is that your first curve, y1? We push enter. Is that our second curve, y2? We push enter. And then we push enter one more time. And it tells us that one of our solutions then is going to be -1, -3. Okay, now we're going to go and find the other solution. So to find the other solution, we're going to do second trace, calculate, intersect. But now we have to get close to that other solution. Otherwise, it's just going to find the same one. We may want to extend our window to go down a little further so we can see that other solution. What would I change to go down further? The y what? Max or min? min. So I want to make my y min go down further. So here's my first function. Here's my second. And now I can see that one a little bit better. If I wanted to make it even better and zoom in a little bit, I might want to go from like -4 to 4 on the x's. I mean, it would still work. You don't really have to adjust your window all this much, but I just want to show you how you can do that, and you can see it even better now. So I'm going to do second trace calculate intersect. I got to get close to it. Enter, enter, enter. And my other point of intersection is at -3, -11. What questions do you have so far? All right. So anytime they ask you to solve the system by graphing, I'd like for you to go ahead and do it on the calculator. Okay? Anything by graphing. Go to the next set. Now, on 4 and 5, I want you to just look at the graphs that they've given you and write down what the solutions are. We don't have to use our calculator. We can just look at the graphs that are given. Risha, can you tell me one of the solutions on number 4?
-1, -7.
Be careful with the units here. It looks like that's -2, -4, -6, -8, so
-1, -7.
good. Okay, and then Sai, what about the other one?
2, -7.
Right. So those are the 2 solutions to that one. And then what about number 5? Abby, what do you think about number 5? No solution. Good. All right, so far we've looked at the graphing methods. Now we're going to look at how we can solve systems by substitution. And these are going to be nonlinear in some cases. So looking at number 6, the first function we have is linear. The second one we have is quadratic. So all we have to do is we just have to say, well, if y equals this and y equals this one, then this can be substituted in right there. So we are just going to have x plus 4 equals x plus 2 quantity squared plus 1. Are we allowed to take the square root of the right side? No. It is addition, and it's not a single quantity. So we have to go ahead and square that out. Can we square this out quickly? X squared plus what? Right. And don't forget that plus 1 that's already there. So now we've got x plus 4 equals x squared plus 4x plus 5. So we've got 0 equals x squared plus 3x plus 1. What are we going to do at this point to solve this? Can it be factored? Are there numbers that multiply to be 1 and add to be 3? No. Anish, what are we going to have to do? We could complete the square. What else could we use? Quadratic formula, either one. You have to decide what's best for you. I think in this case, it's easier to use the quadratic formula. Why am I saying it might be easier to use the quadratic formula? Right. 3 is an odd number. So remember how we're going to have to take half of 3 and square it? It's a little tougher to do that when it's an odd number. So we may just want to go ahead and do the quadratic formula. So I'm going to go with that. So x equals -b plus or minus the square root b squared minus 4 times a times c all over 2a. So now my solutions are going to be -3 over 2 plus or minus radical 5 over 2 Each of those terms is getting divided by 2. But when we're finding these solutions, we have to find out what x is and what y is. So one of my x's is negative 3 over 2 plus radical 5 over 2. My other x is negative 3 over 2 minus radical 5 over 2. And now I'm going to have to substitute those back in somewhere to figure out what y is. So we have to go back up to the start of the function, to the start of the equation rather. So y is x plus 4. So I have that negative 3 over 2 plus radical 5 over 2, and I have to add 4. What am I going to name 4? I'm not going to call it 4. I'm going to call it what? To get a common denominator. 8 over 2, right? So then my solution that's going to go along with this, my y value that goes along with this x, is going to be 5 over 2 plus radical 5 over 2. My other x value was just negative 3 over 2 minus, so I'm just going to change that to subtraction right there. Oh, that was a big eraser. Okay, so now I'm going to have just negative 3 over 2 plus 8 over 2, which is 5 over 2 minus radical 5 over 2. Those would be my two solutions. So how many times do those two equations intersect? Twice. Okay? So that's an example of substitution. I'm not going to do the other two, but I think you get the idea. One thing I just want you to keep in mind is how you would do the problem. So we're not going to actually do the next two, but I would like for you to think of how you would do it if you did have to do it. So look at number 7 for a minute, and I want you to think about it, and then you're going to explain to me what you would do. So who has an idea of what you would do on number 7? What would you do, Anita?
Since it's already equal to y, you just take the next one part of the y first.
Right. So because it's already solved for y, we would think of this, and it would go right in there. And so what would have to happen to this? It's going to have to get what? Squared. And then we'd have to add x squared and equal 16 and do all that. All right. And then, Jacob, what about number 8?
You would replace the y with x.
Right. Once again, this is already solved for y. So right here, where we have this y, we would have to substitute that in and then go through and do all of that work. Okay? Not hard, just takes a while. Okay, let's go over to the next group. So now we're talking about elimination. How do we solve by elimination? Well, in elimination, we want to make sure that we have everything lined up the same way. All right, so watch how I'm going to rewrite this first expression. I'm looking ahead at how this is written. Okay, look at how my second one's written. I want to get this one written in the same way. So I'm going to do x squared minus 7x minus y equals negative 12. Look at that for a minute. And see why I wrote it like that. Can you see how it's equivalent? All I did was I took the y over here and I took the 11 over there. So now I can line these up. So I can make this negative x plus y equals negative 4. See how I'm lining it up so that I can use elimination. And what's the easiest variable to eliminate? Y. So now I can go down and I can just add. I get x squared minus 8x. Those cancel out, equals negative 16. I'm going to kind of think ahead about how I want to do this. I could complete the square, but what about if I brought this over? Would there be numbers that multiply to be 16 and add to be 8? Yeah, so I'm not going to complete the square, I'm going to use factoring. And so now I can go ahead and factor this. I'm going to have an x and an x, a 4 and a 4, a minus and a minus. So I have a solution of x equals 4. So my solution is only x equals 4. I plug it back in, x is 4, so then what's y going to be if x is 4? 0. So that's the only place that those two would meet, is at one point. Can you think of how a parabola and a line could meet at one point? Nish?
It could be a vertical or horizontal line that goes through the vertex.
Yep.
Or it could be just angled that way that it goes so far that there's never reach.
Yeah, and that's called tangent, that last case you're talking about. So lots of different ways that could happen. He said it could be a vertical line. It could be a slanted line that just hits the parabola one time, but it could also be tangent to it. So if we graph these on the calculator, we can see which case it is, but we don't really have to. Is there anything that would be necessary for number 10? We're not going to actually do number 10, but what could we do to eliminate a variable? What could we do? Okay, we could do that. Okay, that would be substitution, and that's totally fine. I'll never tell you a certain way you have to do it. Okay, that would work. How could we do it by elimination? No? Right. If I just multiply this by a negative, then we could go through and we could do the problem, right? Because the y's would be eliminated. All right, we'll go ahead and do number 11. This one's a little tougher. So thinking about getting these set up in the same order, okay? I can either get the second one in the same order as the first, or the first in the same order as the second. I'm going to rearrange this one to make it match that one. So I'm going to have to take my x squared over. It's going to become positive. My y is going to have to come over. It's going to become negative. Oops, I didn't even notice that these are both x squares. All right, so I'm going to have to do a little bit more work here in just a minute. So I took that over. This term, I'm just going to go ahead and take it over here. And then I have minus 29. Okay, now on my other one, I have to get it arranged in the same order as this one now. So I'm going to take this term over. What's it going to become, guys, if I take that over? Negative x squared. This one doesn't change because I'm not moving it. This one I already moved, so it's gone. I don't have a term there, and here I still have negative 1. That's the most important part. If you don't understand something I did there, let me know.
So you have to make both, like, why are you making them both cancel? Couldn't you just do y, like negative y and y?
I could, but I'm not even trying to make anything cancel. I'm just trying to get them lined up. So I kept the second one the same. It's still just negative x. I took this over to get my x squareds together, but it's just negative x squared plus y equals negative 1. So I had to get my first one. I had to get x squared to line up, so I had to bring it over. The y, I had to get it to line up, so I brought it over. The 29, I needed it to go with the negative 1, so I brought it over. See what I'm doing? So what's going to happen to this side then? What's everything going to just be? 0. So I'm going to have 0 equals 5x minus 30. And so therefore 5x equals 30. So x is just going to be 6. And now I can just substitute that in. I've got to decide on the easiest place to substitute it in. I'm not sure there's any place that's that easy. Probably right here would be my best choice. So I'm going to sub it in. 6 squared is 36 times the negative would be negative 36 plus y equals negative 1. So what's y going to be then, you guys?
35.
35. So they're going to meet again at 1 point.
So you don't plug it into the whole equation, you plug it into.
You can plug it into any equation you see on this whole problem. I mean, I could even plug it in here, but is plugging it in here going to be helpful? So I have to find somewhere where I have a y. I can plug it in here, 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 anywhere. All right. So on this one, the sum of two numbers is -5, and the sum of the squares of the two numbers is 17. What are the two numbers? Okay, how many numbers do we have? Two numbers, right? So we're going to have names for those two numbers. So I'm going to say x is the first number. And I'm going to say y is my second number. And you guys, if we have two variables, how many equations must we have? Two. We must have two equations if we have two variables. See if you can write the two equations. Going back and reading the problem. Clara, do you have the equations?
X plus y equals -5, x squared plus y squared equals 17.
Very good. So we have our two equations, and we have our, so we know what to solve for. We have the two variables, x and y. Which method are you going to use? Are you going to use substitution, elimination, graphing? What would you use, Sai? And what would you do to use substitution?
On the first equation, you could just subtract y.
Okay, so, go ahead.
X equals negative y minus y.
Okay, so he's saying we're going to solve the first equation for x. Now, wherever I have an x in this equation, in that circle, I have to replace it with this. So this is going to become -y minus 5, parentheses, it gets squared, plus y squared equals 17. All right, so now we're going to have to square that. So let's think of how we could square that out. I'd love for you to be able to do it very quickly. Anish?
Can you just like eliminate both the negatives from y and 5, make it y plus 5, and it'd be the same thing?
It would be in this case, and here's why. Let me just come over here to the side for a minute. The reason why is because with that -y minus 5, I can really factor a -1 out of that, and then it becomes y plus 5. That would be equivalent to what I have over there. So now I have multiplication. So I would be allowed to do -1 squared and just get 1, and then I'd be able to square that out, and I would just have y squared plus 10x plus 25. So yes, you're right. I can just ignore those. But let me show you the way, too, that you can do it, even without ignoring it. I'm trying to do -y minus 5 times -y minus 5. So this times this is going to be positive y squared. Now I have to do this. That gives me positive 5y. And I have to do that. And so again, positive 5y plus positive 5y is plus 10y. Then I have to multiply those, and that gives me plus 25. So do you see how if you didn't know that whole factoring out of that negative, you could still get that answer? And now we still just have the rest of the problem. Okay, so go ahead and kind of be solving it on your own. I'm going to be solving it up here. Were you guys able to get y equals -4 and -1? Factoring's our best way. Now, I want to find the easiest place to substitute in. I can look anywhere on this paper and substitute in. Where's the best place?
First equation.
I mean, that's not bad. Jessica?
The x equals -1.
Right. See how right here is telling me x is going to be -y minus 5? So if I plug in -4, I have -4, that's +4 minus 5. So that's going to give me -1. Plug in -1, -1, that's +1 minus 5, that's -4. To answer the question, do I really have to write these twice? No. The two numbers, the answers to my two numbers, the two numbers are -1 and -4. It doesn't matter which one's the first number and which number is the second number. Okay? All right, guys, I want to show you how we can do this problem with graphing. I think it's very important that you know how to do this. So if you have any spare space somewhere, or you can just even watch, here's what we're trying to do. Our problem is x plus y equals -5, and x squared plus y squared equals 17. If I solve this first one for y equals, because I got to put it in the calculator, what would this be as y equals? Right, -x minus 5. If I'm solving this one for y, I'm going to get y squared equals 17 minus x squared. How do I solve it for y, though? I have to do what? Take the square root. And what do I have to put in front when I take a square root on an equation? Plus or minus. So how many equations do I truly have? Not 2, but 3. So I have 3 equations that I'm going to have to put in. So try putting these in now into your calculator. There's the linear. Does that look the way you would expect? Maybe, maybe not. Does anybody know what kind of shape that is? It's a circle, isn't it? The radius is a little bit more than 4. It doesn't really look like a circle, and that's because of our screen being stretched in the x direction because it's a rectangle, but it's still going -10 to 10. So I would have to find those points of intersection. This gets a little tricky, watch. I've got to get close to this one. I do my enter, and now look where it jumped to. If I'm trying to find this point of intersection, is that the second curve I want? No. I have to arrow down to tell it I want this. I want the intersection of the bottom part and that line. So now I push enter and enter one more time, and it tells me that the intersection is -1, -4. So it's kind of tricky to get that. Let's find the other one now. Second trace, intersect, get close to it, arrow to the left or right, or to the left to get close, push enter, but now look what it does. It jumps up to that other one. That's not the one I want, so I have to arrow down to tell it to stay down on that lower part of that circle. Push enter again, enter one more time, and we get -4, -1. Okay? All right. Any questions? Okay, good job. So we have our assignment. You can either do it online at section 3.5. You've still got a lot of time. You can probably get most of this done before you go. Also, it's in the book if you'd like. The other thing I'm going to do is let you take a look at your quizzes and work with people around you to figure out what your mistakes were on that, if any.
We had several people get 100 on that, so it's great.
Yeah, hold on just a minute.